Today we have a kinematics question from Edexcel, A-level pass exam. So my advice for these questions is always write your vectors as columns. Okay, so you're much less likely to make silly mistakes, exam pressure, nerves, whatever, if you're just writing your vectors as columns. So I'm starting off with particles velocity. So first thing I'm writing, just rewriting 3t to the half I minus 2tj. Fantastic. Now what does it want? Part A, find the acceleration. Now we know the acceleration is just going to be the derivative of velocity with respect to time. And differentiating vectors is very easy because you're just going to differentiate the I component and the j component separately. So 3t to the half differentiated is going to be 3 over 2t to the minus half. And minus 2t differentiated would be minus 2. There we go. Let's put the units on these as well. So velocity means per second, acceleration means per second squared. B. Okay. Find the value of t at the instant when p is moving in the direction of I minus j. So these questions, they can only ask you a fixed number of things. They could ask you for a value of time when a particle is has a position vector parallel to or in some direction, in which case you would look for r. They can ask about when they're moving in the direction of, that's to do with their velocity. In this case, moving in the direction is velocity. Or they might say accelerating in the direction of. Okay, so acceleration. So here, they're moving in the direction of, so that's velocity. And it's the direction of, meaning it's parallel to. Okay, so velocity is not necessarily equal to I minus j. Again, I'm not going to write I minus j as I minus j. I'm going to write it as 1 minus 1. It's parallel to that. It could be 10, negative 10, 5, negative 5, whatever, right? Parallel to in terms of vectors just means some multiple of. So velocity is some multiple, I'll call it k, of 1, negative 1. In this case, velocity was 3 to the half, negative 2t, right? So 3t to the 1 half, negative 2t is some multiple of 1, negative 1. How you go about solving this is sort of up to you. One safe way to do is just to make this into two simultaneous equations and eliminate the k. Like so. So k times 1 is k times negative 1 is negative k. And in this instance, I would be allowed to divide my equations to eliminate k. Just divide them. So 3t to the 1 half over negative 2t is now k over negative k is negative 1. So 3t to the 1 half is going to be 2t. And when you're solving equations with indices here, like the 1 half, it's usually a bit easier to rewrite the indices with your thirds or your roots or whatever, just a bit easier to visualize. And we'll find the value of t, right? Yes. Okay, so well, since it says at the top, actually, it says t is not 0. Okay, t is greater than 0, so t is definitely not 0. So the quickest way to solve this equation is just to divide both sides by root t. Fully, this would be a disguised quadratic, and you'll get two solutions. But one of those would be t equals 0. So we can we know that's not the case. We can just sort of skip. T divided by root t is root t. Root t is 3 over 2. So t is 9 over 4 seconds. Okay, so 9 over 4 seconds. For part C, we're now talking about the position vector relative to O, which is going to be called R, as it always is. Now, we know for position vector, it's what is the final expression for R, position vector, we need to, instead of differentiate velocity, we need to integrate velocity. And when we integrate a vector, again, it's very straightforward, you just integrate as you would. So the integral of 3t to the 1 half, I raise the power, so 3 over 2, and then divide by 3 over 2, so times by 2 over 3. We're going to get 2t to the 3 over 2. And negative 2t becomes negative t squared. Remember, when we integrate, we get a constant. So when you integrate a vector, you may get a different constant for the I component and the j component. And just like in regular year 12 maths, right, we are going to use some information to find that constant. So we know when t equals 1, r is negative j, which is 0, negative 1. Okay? So when t equals 1, r is 0, negative 1. I've just realised I've used f here. It should have been r. So in SUVAT, they often refer to this as s. It means the same thing. It's the position vector from the origin is the displacement from the origin. So apologies for that. This should have been r. R is negative j, so 0, negative 1 equals, that's when t is 1. So 2 times 1 to the 2, negative 1 squared. When you are substituting it like this, you should really show your substitute with a bracket to gain those method marks. 0, negative 1 equals, that's 2 times 1, negative 1. And we should be able to find C1 and C2. C1, 0 is 2 plus C1. C1 is negative 2. Negative 1 equals negative 1 plus C2. C2 equals 0. So overall, R is going to be 2t to the 3 over 2 plus C1 and negative t squared plus C2, 0. Fantastic. I've got my R, so I'm on to part C. Part D, the largest part here, actually find the exact distance of P from O at the instant when P is moving with speed 10 meters per second. So it's wanting us to find the distance. Now distance is like displacement, it's like position vector, but it's the magnitude of that. So this is going to be the magnitude of the position vector. That's what we're looking for. And at what time? Well, it doesn't just tell us when t equals 4 or 7. That'd be too easy, right? It's telling us at the time, at the instant, when the speed is 10 meters per second. Now, the same way that the distance is the magnitude of displacement, or position vector, the speed, we know, is the magnitude of velocity. So we need to find that time when the magnitude of the velocity is 10 meters per second. So I'm going to go back up to my expression for my velocity, all the way up here. Okay? So 3t to the half and negative 2t. So let's just get that down here. So d. So 3t to the half, negative 2t. That's my v. And because my velocity has magnitude 10, well, how do I calculate the magnitude of a vector? That's when you do your Pythagoras. Right, you square each component and sum and square root. So 3t to the 1 half squared plus negative 2t squared. When I square root it will give me 10. So squaring both sides, get 100, and I'm going to get 9. Now t to the half squared is root t squared is just t. That's plus 4t squared equals 100. So 4t squared plus 9t minus 100 equals 0. Okay, so this is just a quadratic, so I'm going to very happily put it in my calculator. 4, 9, and negative 100. 4 and negative 25 over 4. Okay. And I think we had time being greater than 0 in this question. Yeah, t is greater than 0. So I need to discard my solution which does not fit that. I still show what it was, but I put a cross for it. Here's my final answer, t equals 4. Well, it's not my final answer because the question didn't say find the time, it said find the distance. So this value of the time I'll have to substitute in to r. If t equals 4, r is going to be, t equals 4, well I have 2t to the 3 over 2 minus 2. 2 times 4 to the 3 over 2 minus 2. And negative 4 squared, so it's going to be 4 to the 3 over 2 is 8, so 14 over here, and then negative 16. And so the distance from the origin is going to be the magnitude of this vector, square root of 14 squared plus negative 16 squared. Let's ask the calculator what it thinks. 14 squared plus 16 squared. Can't type that. 452. Square root is 2 root 113. And this is distance. What do we measure distance in? we'll measure distance in meters. So that should be the final answer, and I think that's everything. So I'm going to do another 1 or 2 kinematics ones. I think these are probably the easiest ones there are in the A level. Honestly, if you just need to learn the vocabulary of distance, speed, velocity, moving in the direction of, accelerating in the direction of, distance travelled, once you've got them, it's just integration, differentiation. Okay, so good luck, and let me know any questions.